Hi everybody. So this is my second video in a series on tangents and normals to conic sections in year 12. In this video, we're going to look at finding a normal to a rectangular hyperbola. And if you want to work along with me, you can download a copy of a PDF from my website. I'll leave a link in the description below. So we're told that a rectangular hyperbola H has the Cartesian equation xy equals 16. We're given the parametric equation here, and this lies on H. Part A, we've been asked to show that an equation of a normal to H at point P is given as this. And in part B, we've been asked to use this equation. Okay, so we've been asked to work out the equation of a normal. So this means I'm going to begin by working out the gradient of a tangent. Once we've found the gradient of this line, we'll find the negative reciprocal, and this will give us the gradient of a normal. So to find the gradient of a tangent, we need to find dy by dx, and we're given that xy is equal to 16. So if we move the x to the right hand side, then we'll say that y will equal to 16 over x. And to differentiate this, I'll move the division of x to the top, so it becomes 16x to the negative 1. And when we find dy by dx, we'll bring this power down, and then we'll take away 1 from a power. So we get dy by dx will equal negative 16, and then for the x term, we know this is 4t. And because we're looking at a negative 2, I'm going to write this as a denominator over here. So this will be over 4t squared. So we'll expand out our denominator. We get negative 16 over 16t squared. These will cancel. So the gradient of a tangent will be negative 1 over t squared. This will give us the gradient of a normal as positive t squared. And now we can use the equation of a straight line. We know m is t squared. We can substitute in our x and our y values. So we'll get minus 4t will equal y minus 4 over t. So now we need to expand out this bracket, and then we'll multiply everything by the t to cancel out this term. And then we'll move the t cubed x over to the right hand side, and the negative 4 over to this side. And this is exactly what we were asked to show here, okay? So this is the general equation in terms of t for the normal to h, okay? In part B, we're told that the point A on H has parameter t equals 2, and that the normal to H at A meets H again at point B. We've been asked to work out the exact value of a length AB. So if we say that at A, t equals 2, we can find the coordinates of A by substituting 2 into our parametric equations. This will give us 8 and 2. So I'll plot this about here. And then we're told that the normal at this point intersects the curve again at point B. So I'll label this point here, point B. We need to work out the length A to B. We can work out the equation of this line by substituting t equals 2 into our general equation for the normal. So we'll get 2 cubed x minus 4 lots of 2 to the 4 will equal 2y minus 4. So we'll get 8x. The 4 times the 16 will give us negative 64. We'll move a negative 4 over to the left-hand side. So this becomes negative 60. And this will equal 2y. We'll divide everything by 2. So y will equal 4x minus 30. So this is the equation of a normal. To find this point of intersection, we'll substitute this equation into our equation for the hyperbola, So at B, we'll get x multiplied by y will equal 16. We can expand out this bracket. We'll divide everything by 2. And then we can solve this equation. And we get x equals negative 1/2 and x equals 8. We know our solution for x equals a is at point A. So x equals negative 1/2 must be at point B. So at B, x equals negative 1/2. We'll substitute negative 1/2 into the equation of a line. We get y equals negative 32. And I'll show this coordinate on our graph. Okay, so now we need to work out the length of A to B, and we can do this using Pythagoras' theorem. So now if I sketch this right angle triangle, we know the base will go from negative 1/2 to positive 8. This will be 8.5. And we know the perpendicular height will go from negative 32 to positive 2. So this will be 34. So AB will be the square root of 8.5 squared plus the 34 squared. We can work this out and we get the exact solution of 17 root 17 over 2 units. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.